All right, so today for 5.2, we're going to learn about multiplying and dividing rational expressions. So we're going to build off that concept of what is a rational expression, as well as how to simplify a rational expression. And now we're going to say, all right, this is what we do to multiply that rational expression. So we're going to jump right in here with example one. Example one, and there's a couple ways to do these. You can break down each of the parts where you would say, like, okay, 4 goes into 8, 5 goes into 10, all the different parts that can be broken down. But we're trying to simplify fractions above, meaning the numerator, and below, meaning the denominator, or diagonally. So there's multiple ways that we can simplify this. The easiest way is just to multiply everything straight through and then see what you can simplify. So that's the way I'll show you here for example one. So we're going to look at 4 times, sorry, let me click the draw there. 4 times 10 gives us 40, and then we've got our x and our y squared. Then 5 times 8 is also going to give us 40, and then we've got an x to the 4th and a y. So I just wrote the variables in alphabetical order. So when we look at that, once we multiply through, and they won't all be the exact same number above and below. So when you have the 40 over 40, you know that that becomes 1 or is going to cancel out. So let's expand this out just a bit here. So if we have x and then y squared, that means we have y times y. And then we also have x to the 4th, which means we have 4 x's and then another y. Now you do not necessarily have to write all of your variables out every time, because that would be fairly time consuming depending on the number of variables you have. But in this case, I'm just showing you the first example, so that's the reason I did it. So our x above and our x below, one of them can cancel out. Our y above and our y below, one of them can cancel out. So what we're left with is a y in the numerator, so right there. And then we also have 3 x's, which we know is x to the 3rd. All right, and that would be your final answer for example 1. So when you do these, that is one way, is just to multiply all the way through. That's the way I would recommend, just because it keeps everything nice and condensed. You can try to simplify diagonally before you begin, or even in one numerator and one denominator of your first or second fraction. But we're going to just stick with multiplying our way through. So 7 times 2, when we're looking at our value there, we know that that's going to give us 14. And then when you are multiplying exponents, remember, you are adding those. So an x to the 4th times x to the 7th, you're adding those exponents. So what that gives us is x to the 11th, and then we still have our y to the 3rd. On the bottom portion, we have a 5 times 10, so we know that that is 50. And then we have an x by itself. And then the y's, again, you're going to add your exponent. So this would be like y to the 1st times y to the 5th, which is y to the 6th. All right, so that puts everything all together under one fraction, as opposed to being 2 separate fractions that we're multiplying. So now we're just looking to see, is there any way to simplify our numbers? So when we look at our numbers here with our 14 and our 50, we know they're both even, if nothing else, so we can divide by 2. So 7 over 25. Then when we are trying to simplify, like I was saying, we don't have to write out 11 x's every time to do this. We just know there's 11, and that when you have one x below, it's going to cancel out one of them. Another way of saying that is when you bring an x to the 1st up top, it becomes an x to the negative 1st, and then you'd have 11 minus 1. But that does get kind of a little muddled up at times when you got 1 on the bottom, 11 on top. Just take away 1. So we're going to write it in that form. Then we've got 3 y's up top because we have a y cubed, and then we've got 6 of them on the bottom. So you're going to take away the 3 up top, and then you take away 3 on the bottom, so you're left with 3 on the bottom as well. All right, so 7x to the 10th, and then 25y cubed would be our final answer when we multiply or find that product. All right, let's look at a couple more. So now what we've got here as we are looking is saying, well, now it's like a trinomial and a binomial. What do we do with this? But just take it part by part, bit by bit, and you'll see that you can still cancel out a lot of information with most of these problems. So when we're looking through, And we see, and this is what I was saying, there's multiple ways. You can just multiply this through or write them next to each other. Or another way is to say 4 goes into 40. So I know that I would take out a 4. And then I've got x plus 10. And this is something we learned in Unit 1 as far as how to simplify a individual expression. So if we say 4x plus 40, we can now say 4 times x plus 10. The bottom portion, this is where the factoring is coming back. So our factoring has now made a reappearance here. So we see that we have x squared plus 8x minus 20. You can do your grouping method. You can do your x factor. The x factor is the way that I would go with this one. So we know that this is going to be x and x. And I'll fill all this out here so we can see that our a times c is negative 20, our b is 8. So when we're looking for our factors of 20, we know that we could have 1 and 20, 2 and 10, no 3, 4 and 5. But we need an 8. So if we need an 8, that 2 and 10 right there, that could, if we have a negative, give us an 8. And so that's exactly what we'll need here, is that we would need a negative with the 2, because we want a positive in the middle. So then we know that this is going to give us a negative 2 and an x plus 10. All right, so we're adding multiple parts into one potential multiplication where we're trying to find the product and see what happens. So when we look at this is where I was saying you can cancel this out diagonally now. So you could say x plus 10 and you could mark both of those out. I'm not going to do that just so you can see it all under one fraction, but if you wanted to, that would be acceptable to cancel that out. I, again, would probably cancel it out right away just to simplify things on my end, but just wanted you to see it all together. All right, so with it all together, this is what we have, and then that x plus 10 would cancel out, so those are gone. So if you don't want to have to write that all together, you can cancel it out right there with two separate fractions. You could also cancel out diagonally, because we know 3 goes into 9, so that would become a 1. This would become a 3. And then we know x and an x squared, this would become a 3x. Or if you're like, I don't really see that diagonally, you could see it under one parentheses that we have on the right side here. And you could see again, we have a 3 and a 9. So the 3 goes into 9 3 times. And then one of our x's is going to be taken away, leaving us with a 3x. So up top, that leaves us with a 4 times 3x. So that leaves us with 12x. And then on the bottom, that just leaves us with an x minus 2. All right, so multiple steps, all in one problem that we're finding the product with two fractions. You got to be able to factor. You got to be able to take out a greatest common factor. So things from previous units are now coming back. Like we said, we build off of a lot of this stuff. So we'll look at example 4 together as well, and that'll be it for this portion of the video. When you look at the first fraction, hopefully you say dots, yes, all right, I know that all I have to do is say x with a positive and a negative, and then 4 and 4, meaning it was a perfect square in both locations. So we have x times x gives us x squared, 4 times 4 gives us 16 with a positive and with a negative. The bottom right here, when we see a 3 and a 12, we know that 3 goes into 12 4 times. So we got a x minus 4. So we're already feeling okay because of the fact that the x minus 4 is going to cancel out. And then when we look in the bottom left, you can again do grouping, you can do dots, you can do whichever way that you prefer. But we know x and x, we know 2 and 2, they're all positive, so these are going to be positive. So that is factored out, whether you did dots or bottom right greatest common factor, or bottom left you could have done x factor or grouping. You kind of can take your pick there. But what that gives us is now we can cancel out this x plus 2. We know we can cancel out this x minus 4. So when we write this, we are already narrowed down to x plus 4. And then we have our 3. And then our x plus 2. And then now that's all we can do at this point. All right, so we'll elaborate a little bit further as far as dividing these fractions, but it's very similar to what you're seeing here in this first video.